time in periods 2 and 3. So I can't dilly-dally. Here comes example number 2. I want to remind you, we have a table, and we have a ball rolling off the table, going 5 meters per second. This table is 1.5 meters above the ground, and the ball ends up going here. Did we get this far to where we drew a drawing? Okay, great, great. The big thing I need you to be aware of is whether you've got a ball rolling off the table or you've got a car driving off a cliff. If you've got something whose initial direction of motion is horizontal, then that initial velocity is its initial x component of velocity. And it turns out the initial y component of velocity is 0. You guys okay with that? Because it has no y component of velocity. It's neither going up nor down. Step 1 says, find the time it takes the ball to hit the floor. Well, which direction are we going to consider when trying to decide how much time it takes this ball to hit the floor, the x or y direction? I hope you're seeing it's the y direction. In the same way that if this were a boat and I wanted to know how much time it takes to cross the river, I would not care about the current. I would only care about how much progress it's making across the river. Well, that's what's happening here. We need to see how much time it takes the ball to hit the floor. And so that's the y direction we're considering. We're going to learn later on that whether the ball is launched at a horizontal speed or whether the ball is just dropped, it ends up taking the same amount of time to hit the floor either way. We're going to see that. I even have a demo that demonstrates that. So anyway, to do part A, and I'll do it with you. To do part A, we've got to consider the y direction only. So let's collect our information in the y direction. You know the initial velocity in the y direction is 0. The acceleration in the y direction is negative 9.8 meters per second squared. By the way, by making it negative 9.8 meters per second squared, I'm defining up as positive, and I'll define the right as positive. So I'll tell the world, hey, up is positive, and to the right is positive. I know the displacement is 1.5 meters. You guys tell me, is it positive or negative 1.5? Yeah, you guys are saying negative, and you're correct because it's falling down. So the displacement is negative 1.5 meters. And now I'm going to find the time. And the formula that has those 4 quantities is y equals 1/2 a t squared plus v naught t. Equation number 3. And now I can plug in negative 1.5 equals 1/2 times negative 9.8 times t squared plus 0 times t. And I end up with t equaling 0.55 seconds. Just trust my math. Any question or problem on this? Alrighty, let's do part B, the velocity of the ball when it hits the floor. The velocity of the ball when it hits the floor. Let's consider the velocity of the ball every step of its way. Okay? I want you to see that in the x direction, the velocity is not going to change. When you're in free fall, then your x component of velocity never changes because there's no force acting on you. There's no air resistance to slow you down. There's no one pushing on the ball to speed it up. And so there's no change in velocity in the x direction. So its initial velocity is 5 meters per second, and so that velocity just stays 5 meters per second the entire trip, okay? But the y component of velocity is changing. As it falls, it goes faster and faster in the y direction. Here the y component of velocity is 0. Here the y component of velocity is a small amount. Here it's a bigger amount, and there it's a bigger amount. You see? As the ball falls, it goes faster and faster in the y direction because the acceleration of gravity is 9.8 meters per second in the y direction. And so to answer B, to get the velocity that this ball has when it hits here, I'm going to have to get the x and y components of velocity. This will be the final velocity in the x direction. This will be the final velocity in the y direction. And then I'll do Pythagorean theorem and inverse tangent to be able to answer the question, what's the final velocity in the y direction? So hey, I'm going to do that now. You'll be doing it shortly on example 3. You're going to do this yourselves. And here comes part B. The final velocity in the x direction is 5 meters per second. That's easy. So let's go ahead and get the final velocity in the y direction. Well, you know the initial velocity in the y direction is 0. You know the acceleration in the y direction is negative 9.8. You know the time it took to fall, 0.55 seconds. And you're going to find the final velocity in the y direction. Alrighty. Well, the equation that has that is v sub y equals at plus v naught y. However, is there anyone in this class who knows, since I'm just starting from 0, all I got to do is multiply those two guys together and I get the final velocity? If you do it that way, more power to you, that's fine. That'll work on exams. You don't have to do things my way. I just tend to do the formulas because that's the way I taught it. So I got negative 9.8 times 55 plus 0. So I get v sub y equals about 5.4. Alrighty, cool. So now I know my x and y components of velocity. Now I'm going to have to do Pythagorean theorem and inverse tangent. And like I said earlier when I was going over homeworks, because we tend to measure our angles relative to the horizontal, when we do inverse tangent, we tend to use the y component over the x component, because we measure our angles relative to the horizontal. So let's go for it. The magnitude of v is going to be the square root of 5 squared plus 5.4 squared. It is about 7.4 meters per second. Now the angle will be the inverse tangent of 5.4 over 5, which ends up being about 47 degrees. Just trust me on that. And so we get our final velocity. And our final velocity is going to be 7.4 meters per second, 47 degrees south of east. And that's the answer. Question? Yes?
Why is the Vy? Why is it not negative? Why is it positive?
Oh, I don't know. I just forgot it. Okay. Yeah, thank you. Alrighty. And then, any other questions on part B? Okay, then let's do part C. Part C, now they want to know how far it went in the x direction. How far from the table this guy fell? What is its range? Well, in the x direction, because there's no acceleration in the x direction, what's the only equation I get to use in the x direction? Thank you very much. X equals vt. X equals vt, that's all I got. All of the kinematic equations simplify to x equals vt, or they simplify to v naught equals v when you have no acceleration. So let's go for it. I know my velocity in the x direction is 5 meters per second. I know my time is 0.55 seconds. So I get x equals 2.75 meters. Any questions or issues? Then I'm going to give you a problem that's pretty much the same as this, only with different numbers, and it's example number 3. I'd like you to please start doing example 3 right now, and I'm going to walk around and help you. Do you pause the camera at a time like this?
Do you want me to?
What's that?
Do you want me to?
Yeah, I think so. Just don't forget to unpause it. Yeah, 2.7 or 2.67 for the time. Oh, Earl, we're Which calculator did you take? Which number on the back?
Oh, supposed to be.
Digital number.
What? Where'd you get that thing? Oh, you disconnected it? Oh, no, you're supposed to take one of those. Those are the student calculators. So what you do is you grab a student calculator and then put that under the paper thing. Wow, that's pretty.
Did he take your calculator, Mr. Shana?
Yeah, he took my special calculator.
Bad Stanley.
Oh my God. My special graphic. Okay. Do you know who that was?
That was Kenneth.
That was
Kenneth.
That was not
That was not Kenneth? I thought that was Kenneth.
Yeah, that was Kenneth.
Yeah, that was Kenneth.
No.
Yeah, he's not wearing glasses today.
Yeah, he doesn't wear glasses.
Contacts.
What happened?
But he has shaved head. Did that guy have shaved head? He's shorter than Kenneth Chan.
That was not Kenneth.
That wasn't Kenneth. No, that was
That
Kenneth.
was Kenneth.
Oh my God.
I was just waiting.
He didn't look like Kenneth today.
So I'm not
No,
crazy.
you're not crazy. You're not crazy.
Okay, hey guys, I gotta zip through this.
No, it was not.
Okay. Are you okay that the final velocity in the x direction is 25 meters per second? That's not going to change. The only thing we have to find is the final velocity in the y direction. And the final velocity in the y direction, since you're starting from rest, it's going to be the acceleration in the y direction times the time. Okay, so I'm getting a final velocity in the y direction of, just a second, 9.8 times 2.67, about 26.2. But if you round it differently, then you'll get a different answer. You might get a bigger answer if you use 2.7, okay? Is there any question or problem? Oh, so I got the x and y components of velocity, but that's not going to answer the question. I need to now get Pythagorean theorem and inverse tangent. And if you don't mind, I'm not going to go through this again. I'm just going to write down the answer. So when I do Pythagorean theorem with 25 and 26.2, I get 36.2. So my velocity is 36.2 meters per second. And now I've got to find the angle. And to get the angle, I'm going to do the inverse tangent of the y component over the x component. So inverse tangent of, what is that, 26.2 divided by 25. So I'm getting like 46.3 degrees. 46.3 degrees south of east. So that's going to be my final answer for the velocity. Any question or problem on that? And then finally, part C, they want to know where it lands. They want to know its range, essentially. And then I'm just going to do x equals vt. And the velocity in the x direction is 25 meters per second. And the time it falls is 2.67 seconds. So I get 25 times 67 seconds. So I get about 66.8 meters, or about 67 meters. Hey, any question or problem on this example? Okay.
So for D, you found the x and the y component, and then just the Pythagorean theorem. Okay.
Absolutely. I found the x and y components separately and then did Pythagorean theorem and inverse tangent to answer their question. Okay, now any other questions or problems on example 3? Okay, now it's time to read example 4 and also read the bold-faced keys, those 2 keys to example 4. Please read it now, then we're going to go through it together.
The camera has finally stopped shaking. I like it.
Is that?
It's not shaking anymore because it's trying to follow you.
Oh, so it's not doing that
Yeah,
bad thing.
it's not doing it anymore.
Sweet, so that's better, right?
Yeah.
Good job, Leilani. Thanks for figuring that out. Stupid camera.
Stupid
It's a
technology.
handy cam, but I've not found it to be very handy. Okay, so let's do example 4. Step 1, I urge you to always make a drawing. Make a drawing of the situation. Here's the ground, and I'm going to throw a ball up with a speed of 32 meters per second at an angle of 52 degrees. Since I'm having to treat the x and y components separately, you tell me what's the first thing I'm going to have to do here. What's that? What? Find y? Well, what do I do with this? Like, is this 32 meters per second at a 52-degree angle? Is this useful to me right now? Can I start plugging in numbers with these numbers right now? No, I need to do something to this first. What do I need to find? Yes, Fatima?
Sine and cosine.
Yeah, get the x and y components, the sine and cosines, right? You've got to get me the x and y components. You can't do two-dimensional problems unless you get x and y components of everything that's at a weird angle. So let's go ahead and get the x and y components. And by now, I'm thinking you guys are good at it, so I'm just going to put the answers up. 32 cosine of 52 degrees, which this is 19.7 meters per second. That's the initial velocity in the x direction. And then I got 32 sine 52. So it's 25.2 meters per second, which is the initial velocity in the y direction. All right. Can I ask you this question? Will any of my subsequent calculations ever involve 32? No, no way. You're done with 32, right? You're done with it. You will never see it again. Just like an old boyfriend or girlfriend. Once you break up with them, that's it. You're done with them. They will never, figure in any subsequent calculations in your life. See what I mean? And if they do, then it's not healthy. Okay, great. Well, let's go ahead and answer their questions. They say, A, get the maximum height of the ball. So this ball is going to go up like this, and then come back down and hit the ground right there. Alrighty? And they want to know this maximum height. Well, first of all, you tell me, which direction am I considering, x direction or y direction? Y, right? I mean, this is a y thing. This is a vertical distance. So yeah, it is y. I got to consider the y direction. So to do part A, I'm going to consider the y direction. And so I've got my initial velocity in the y direction, which is, what, 25.2 meters per second. I've got my acceleration in the y direction, which is negative 9.8 meters per second squared. I'm calling it negative because I'm going to define up as positive and to the right as positive. So my initial velocity is a positive velocity, but my acceleration is a negative acceleration because up is positive and down is negative. Okay? I want to know what that maximum height is. And that's all I've got. Is there another piece of information I can get from this situation? What else do I know? Yes?
Velocity at the end is zero.
Say that again.
Velocity at the end is zero.
If the velocity at the end is zero, is that what you're saying? Yeah. You guys okay? What's the y component of velocity here at the top of this travel? 0. What's the x component of velocity at the top of this travel? 19.7. That's never changing. It's going to go 19.7 the whole time, even at the top of this travel. But the y component of velocity is going to be 0 at the top of this travel. Good for you. So that's the missing link. So now you've got these 4 pieces of information. So you're going to use vy squared equals v naught y squared plus 2 times a times y. Alrighty. So I got 0 squared equals 25.2 squared plus 2 times negative 9.8 times y. And so I get y equaling 25.2 squared divided by 2 divided by 9.8. So I got 32.4. You guys okay with that? What other part do they have? How far did the ball go in the x direction before it hit the ground? They want to know the range. How far did this ball go? in the x direction before it hit the ground. Well, I hope you see you're going to have to use x direction. And since the acceleration in the x direction is 0, the only formula you'll ever use in the x direction for these free fall projectile motion problems is x equals vt. So I've got x equals the velocity in the x direction, which is what, 19.7 times the time. But I don't know the time. I don't know how much time the time spends in the air. Does someone have a strategy for me? How am I going to figure out how much time the ball spends in the air? Because I don't know that time, so I can't answer part D. Yes, Maxwell?
You have to use the y component.
Y component?
To know where the ball stops. So y will equal 0. And so it gives so velocity in the acceleration. Because time it takes for it to hit the ground.
Okay, so here's what Maxwell's going. He's going, when it hits the ground, its y is 0. Its displacement is 0 when it hits the ground. But definitely, do you guys see that to get the time in flight, you're going to have to deal with the y direction? So even though they're asking for an x direction quantity, we can't do it without dealing with the y direction to find time. So here's Maxwell. He's going, well, I want my displacement to be 0 because I want the time for it when it hits the ground. I know the initial velocity in the y direction is 25.2 meters per second. I know the acceleration in the y direction is negative 9.8, and I'm going to find that time. Okay, and the equation that has those four quantities is equation number 3. So I got y equals 1/2 times negative 9.8 times t squared plus 25.2 times t. And by the way, this y is equal to 0. Alrighty. So now I'm going to have to factor. So I got 0 equals negative 4.9 t times, well, no, I won't do that. I'll just factor t out. So I'll factor t out, and I get negative 4.9 t plus 25.2. Are you guys okay with that factoring I just did? That I have negative 4.9 t squared plus 25.2 t, and so I factored t out. So I get two answers. I get t equals 0, and I get t equal 25.2 over 4.9, which ends up being 5.14, if I remember from last year, 5.14 seconds. Okay. Yes?
Could you also find the time at the maximum height and double that?
Noel says, can you find the time it takes to get to the maximum height and then double that? What do you think? Darn straight. So if you don't want to do Maxwell's way, do it Noel's way, right? Noel's way says initial velocity in the y direction is 25.2 meters per second. Final velocity in the y direction is 0. Acceleration is negative 9.8. Find me the time. And now you're going to be using this equation. Okay? And you'll end up with t equaling 2.57 seconds. And the only thing I would say is, since you're doing Noel, since you're finding the time it takes to get there, you know, you better remember to double time. On an exam, if you don't double time, I'm going to take points off. So your time ends up being 5.14 seconds. Great. Was anyone thinking of doing it a different way than Noel or Maxwell? Was anyone thinking of the final velocity being negative 25.2? Was anyone thinking of that? You were? Good enough? Yeah, because if you have your final velocity being negative 25.2, then you use this equation and you don't have to double the time. You'll just find the time. So be aware of what process, what procedure you're using, and you'll be fine. But regardless, you end up with 5.14 seconds here, and so you end up with a displacement of, I think it was like 101 or something, 103, I forget. Approximately 100. Okay. Hey, you guys ready to try a problem on your own? Or is there any question or problem on this process of first get the X and Y components of that weird guy, know that you will never use 32 again for the rest of the problem, and then just do your X and Y directions just like you've done before. Okay, then please start example 5. And we'll go through it at the very end. Yeah, did you have 5200? Did anyone get 5,200 meters for the range? Okay. Well, if Fatima got it, then it must be right, I guess. Did you get 52?
Well, I got 5180, but.
Oh, I rounded to 2 sig figs.
Oh, yeah.
So did anyone, if you rounded 2 sig figs, did anyone get 5,200? Cool. Okay. Is there any question or problem on that? Finding the time and then the distance thing? Uh-oh. Oh, well, what is the other thing you have to find? The height? What did you guys get for the height? 577? 977? Okay, so it looks like people are getting 977 for the height. Okay. So, hey, good luck. Tonight's homework is really going to be very much like these 2 types of examples. Either you're going off horizontally or you're going up at an angle.